Okay, for this example, we're going to once again classify the stability of the origin, and that's going to require us to find the eigenvalues. And again, our matrix A for this problem is a -2, +5, -2, and +4. So as always, we subtract lambda off the main diagonal. And then we set that determinant equal to 0. So that's going to give us -2 minus lambda multiplied with 4 minus lambda plus 10 is equal to 0. That's -8 plus 2 lambda minus 4 lambda plus lambda squared plus 10 is equal to 0. That's lambda squared minus 2 lambda. That's like plus 2 is equal to 0. And then we can solve this by completing the square since it's not factorable. So this is lambda minus 1 squared plus 1 is equal to 0. So lambda minus 1 squared is equal to -1. So lambda minus 1 equals plus or minus I when we take square roots at both sides. And so lambda is equal to 1 plus or minus I. So now, if we think about that, if we've got lambda values that are equal to 1 plus or minus I, they are complex numbers, and the real part of this is equal to 1, which is greater than 0. So that's going to make this a spiral source. And a quick sketch of that is that we are going to start near the origin, and we're either going to spiral clockwise or counterclockwise depending on the actual coefficients in the system. And you can actually read in the Polking textbook how to figure out if it is clockwise or counterclockwise. But for right now, it's good enough just to know that it's a spiral source for us.